In this video, we're going to be looking at another type of function. This one's called a quadratic function. Again, our essential question, how can we model relationships between quantities? Quadratic functions are a special type of nonlinear function. So before this, we talked about linear and nonlinear. A quadratic function is a nonlinear. It's still a function. It just won't be graphed to make a straight line. It's a function where the input variable, which we typically think of as the x, is going to be squared. The graph of a quadratic function will be U-shaped, either going upward or downward, and this U shape is called a parabola. So when I refer to the parabola, I'm talking about that U-shaped graph. A quadratic function is written in the form y equals ax squared plus bx plus c. So it's a little longer than that linear function, y equals mx plus b, that we're used to seeing. So here's where I was talking about the input variable is squared. So the highest variable is going to be that power of 2. So a quadratic function, one indicator there is that your input variable is going to be squared. To graph a quadratic function, they're going to, you'll be given that quadratic equation. You'll want to make a table of values, and then when you plot those ordered pairs on the graph, you want to connect those points with a smooth curved line. So you have that U shape, whether it's upward or downward. And one side of that graph, the parabola, will be a mirrored image of the other. So I'm going to do a really rough look of what a parabola kind of looks like. So if this was our x and y axis, we have a point called the minimum. That's your vertex. Your parabola kind of goes upward. The other side is going to be a mirrored image. So you're going to have what's called an axis of symmetry going right down the center, and the two sides are going to be the same distance from that axis of symmetry. So here's an upward parabola. You can also have a downward parabola. Sometimes they can be stretched out wide, sometimes they can be stretched out lengthwise, so they're very narrow. It just depends on what your coefficients are in your quadratic function. But those are what our graphs are going to look like when we plot those ordered pairs on the coordinate plane. So very quickly, we're going to do an example. We're going to graph the quadratic function y equals x squared plus 3x plus 4. So you're still going to want to do your table of values, which is nothing different from what we've done. You have your input, which is your x. You have your output, which will be your y. Your function rule is that expression x squared plus 3x plus 4. Then you're going to pick some values. Now with a parabola, you might want to do more than 4 values. You might want to kind of get up to 5 or 6 so you can really see how both sides will look. It just depends on what you choose as to what part of that parabola you're going to see. I'm going to go with -2, -1, 0, 1, and then 2, and then see where we can go from there. So we're going to plug -2 in for x, both places. So that's going to be -2 squared plus 3 times -2 plus 4. -2 squared, make sure that negative is being squared as well, so that you're getting a positive 4. Plus 3 times -2, which is a -6, plus 4. So 4 plus -6 is a -2. -2 plus 4 is a 2. So when -2 is your input, positive 2 will be your output. When we put a -1 in, slide that down just a little. We're going to be doing -1 squared plus 3 times -1 plus 4. -1 squared is a positive 1. Negative times a negative is positive. Plus 3 times -1, which is -3, plus a 4. 1 plus -3 is -2. -2 plus 4 is 2. So -1, 2 would be your next ordered pair. All right, then we put a 0 in. 0 squared plus 3 times 0 plus 4. 0 plus 0 plus 4 would give me a 4. So 0, 4 would be my next ordered pair. Kind of running out of room, but let's put a 1 in there. That's going to be 1 squared plus 3 times 1 plus 4. So that's 1 plus 3, which is 4, plus 4, which is 8. Then you can also put the 2 in. 2 squared plus 3 times 2 plus 4. That's 4 plus 6, which is 10, plus 4, which is 14. So that gives me 1, 8, and 2, 14. Okay? We're going to graph those and then make that curved line. So what I want you to do tonight is, after this video, graph these ordered pairs. See if you can get that parabola look. I'll be looking at those when we come into class. I would also like you to get a table of values for this next function. So I'll give you a second, copy those down, pause it if you need to. Make sure you have your work in this table and these ordered pairs graphed. And then I also want you to make a table of values so that we can graph this quadratic function. So y equals, 2x squared minus x plus 4. So again, make a table of values. You're going to pick your x. 2x squared minus x plus 4 would be your function rule. That's going to give you your y's. So I want you to pick your own values, pick about 6, and then be ready to graph that when we get into class.